So when I think about Jupyter Notebooks, actually, I have a like a dual feeling. So sometimes I really like it to use Jupyter Notebooks, and sometimes I don't, and I don't think it's like the best practice to use that. And I guess the whole point of this session is to learn about Jupyter Notebooks and see what are the main strengths of it and what are the pitfalls of it. So Jupyter Notebooks are not the answer to do everything, but it can be a very powerful use for sharing the code, for doing some experiments, and you're going to learn that hopefully in this session. What are the Jupyter Notebooks and what is the main motivation behind it? So when you think about like a pure file, like a coding file, like a Python file or like a C++ file that you have the code, the only way that you can annotate the code is to add some comments into it, right? But Jupyter Notebooks bring another way. And in addition to your code, you can have text, markdown, an HTML code, or like a equation, figures, and everything all integrated into a same document. So you have more ways to annotate your code and explain the workflow and explain the data and also play with the data. So this is a screenshot of like two different Jupyter notebooks. And on the left, you can see that we have a block of code. And in Jupyter notebooks, in these blocks are called a cell. So we have a cell of code. And the output of the code, which is a table essentially, is also shown there as well. But on the right, you can see that there are like some headings, and with the text, it can be like some equations, or as you can see, there are like some tables here as well. So the code is running, and also you can see the result. And when you're saving it, you can see all of the material at the same place, not just your code.
So
Uh,
it's really nice for telling a story. And yeah, one additional reason, so you can do nice formatting and so on to make it like easily readable, the tables look better and so on. But one big thing that to me is especially important is that the output is immediately after the input. So you can actually tell it in order, and the comments are usually pretty far from wherever the output appears in the terminal or
Yeah,
wherever you
exactly.
run the
So
code.
like when you're like coming back to your experiment after a couple of months, or like when you're sharing your code with someone else, it's like very, very easy to follow because you can see the code, you can see the output, and you can also add some explanation like equations or text or plots to support that. So as I mentioned, a Jupyter notebook can be thought as like a notebook, like your paper notebook that you have, but it also has your code, your equation, your text, everything inside, and it's like very easy to share and like to like read and follow block by block or cell by cell. A fun fact is that the Jupyter name is coming from the combination of Julia and Python and R, but today you can also use it with other languages, and there are like some kernels that you can use for other languages to apply to Jupyter Notebook. Um, so Jupyter Notebook format, like as we see here, is like commonly used, and I guess it's more popular nowadays. I have like seen some entire books written in Jupyter Notebook formats, and I guess you have been also seeing that here and there, especially if you have worked with Google Colab. Google Colab, like the interface is essentially a Jupyter notebook that you have different blocks that you can add text or code in it. But the Jupyter notebook formats can be also run, for example, in VS Code, which we hopefully show in a short demonstration, and also GitHub Codespaces also support the similar interface that we can take a look.
There's also Pluto, which is more directly like a Jupyter notebook these days. So
Mhm.
it's a Julia thing, um,
Yeah.
and has a somewhat different philosophy, but I've seen it a lot lately.
I never worked with Pluto, but when I was doing Julia, it was mainly the Jupyter Lab thing to work with Julia. But
Yeah.
okay, it's interesting. I will check it out. So actually, maybe we can take a look at an example. So here we have like two different examples that you can go ahead and browse. I guess in the past CodeRefinery sections lessons previous years, we always look at the wave discovery thing. So maybe this year we can look at the activity inequality study, I guess. But maybe I can also briefly show the first one as well. So the activity inequality study was a study, I guess, in 2017 from Stanford University, and it demonstrates inequality of activity in between different countries and inside the country between the different genders, different race, and different age groups. So just to see what the Jupyter Notebook looks like, you can go ahead and look at the paper, but just to see how are the plots created in Jupyter Notebook, maybe I can go ahead and open the GitHub repository very briefly. And for example, maybe I can take a look at the figure number 3. And you can see that IPython notebooks, these are the Python notebooks, like Jupyter notebooks, that you can open and see. Let's, for example, open the figure 3 section B and C. So yeah, these are essentially like the sections or the cells in a Jupyter notebook. So you can see there is a cell like a cell with code inside. There is a cell, for example, with a text or a heading for the weekday here, and there are like some reading of the data. And when the code is run and the plot is shown, as Jarno mentioned, it's like very nice that you can see actually.
Yeah,
Yeah.
although in this, yeah, I guess
Mm.
the gravitational wave notebook is more like an actual story. This is
Yeah.
more like it's code with very little even comments about it. So this is essentially just the code that produces the plot.
That is true.
And it
That
is
is
in
true.
a Jupyter notebook.
Yeah.
But you can see the plot, so that's nice.
Yeah, but I guess it shows it shows the how the Jupyter Notebook cells are created. But maybe yeah,
Yeah,
that's true. Maybe we can go back to the code
yeah. So
page.
this is not like necessarily a bad example, but
Mm.
I think the gravitational wave thing is a better example in that it actually tells a story.
Yeah. So maybe I can actually go ahead and open the tutorial here. So for example, the quick view notebook. So you can either run it in Google Colab or you can open it in My Binder. And My Binder is I guess we're going to talk about it in the sharing section of this course.
Yeah, yeah.
But yeah, My Binder essentially is a tool that you can share your notebooks, and it would take care of all of the dependencies that you have for example, your Python code, all of the libraries, or if your code isn't run with all of the packages, it would be installed. So when you're sharing the code, everyone can access it and they can also run the code and see the plots and everything. So if I click on My Binder here, I guess it would take a
Let's
couple
see
of
how long it takes.
seconds. I guess like 10
And
seconds or
yeah.
so, but behind the scene probably is like opening the environment and activating the environment.
Oh, it had it pre-created. So yeah,
Oh, okay.
it is possible that it will just create, it will build and create the entire environment where the code can be run.
Mm,
Because the main thing about Binder is that it doesn't just display the notebook, you can
yeah,
actually run the code in the notebook.
exactly. So you can see that again that I have different blocks or different cells, and this cell has like the markdown on headings and everything, and these are like Python codes. So I can go ahead and select the cell, and for example, run the code, and I can like change the code as well. For example, I can do the experiment with like changing this one to L1 as it's mentioned here, and run the code. And this is a raw text, so it doesn't, if I run it, it doesn't change the headings or anything. I can go ahead and run for example, the next block of the code as well, and also possibly running the time series. This would possibly take a couple of seconds as well. And then after the time series is done, maybe we can plot it again so we can see the difference in plot. But I guess because we only changed it from H1 to L1, the plot would just slightly change, but
Well, let's see.
let's see.
Okay, I
Yeah.
don't actually know if there's a difference, but well,
Yeah, it has slightly changed because I ran it before when it's a slight change, but still you can see that
okay,
but you can like do the plots that you can change the colors and everything.
yeah,
But the idea is that we're like going to talk about like more details, like what you can do with the cells. But just to give you an idea, I think this is enough.
yeah,
So yeah, maybe I can go back to the course material. I don't save it, I would go back. But you can like feel free to go and browse the more figures and see what is happening. So as I mentioned at the beginning, when it comes to the Jupyter notebooks, I have it like a dual feeling about it. And because Jupyter notebooks are like very good in some of the use cases, especially when you have a workflow that is linear, which means like you have like some data and you want to like do some experiments on it, and you're pretty not like it's like an iterative approach that you want to apply. So these are like very, very good use cases for Jupyter notebooks. Experimenting with new ideas or with new libraries, or when you have like a new data set that you haven't worked with it, again, it's like very good because you can play with the data, and as Jarno mentioned, you can see the results immediately afterwards. So you get a better sense than writing a code that reads the data and then you have to like recompile the code every time. I see Jupyter Notebooks as like an interactive way to work with your code and data specifically, because you're changing something and you're seeing the results, you're changing the something and you're changing the results. And with the more powerful like things like widgets that we are going to discuss, you can actually make your Jupyter Notebook more interactive, which is like a very fun way to play with your data. These days, a lot of HPC clusters also provide like a Jupyter ready environment. So for example, here at Auto on Triton, we have a Jupyter available on the web browser. Also, Lumi supports that. So in addition to like playing with your data, you can actually run it on one of the compute nodes with all of the fancy resources of many CPUs to a huge memory or even GPU cores in some of the clusters, which makes playing with the data even more fun, I guess. Um, Sharing and explaining the code to others, or like to just remember it in the future, it's actually very good. As Jorno mentioned, like telling the story behind like why I'm doing this experiment, why these hyperparameters are set, or like just writing the story of uh, what you are doing in the code is like a very powerful use case of the Jupyter notebooks. If you're a teacher and if you're teaching something, it's also a very, very good use case. As I mentioned, I've seen entire books written in Jupyter Notebook. And I remember when I was a student in many of the computer science courses, we had a lot of the assignments were in Jupyter. That the idea of the assignment were there, the story were there as well, and some of the blocks of the code were empty that the assignment was meant to like for the students to fill it out.
Okay.
And I guess it's like also very easy for the student, for the teacher to grade these kind of assignments as well, because you just run all of the code and see. And even if you don't run it, you would see the plots and the output. So you get
I think
an
there is
idea.
also there is an automated grading system for Jupyter notebooks, but then you have to essentially have a correct answer.
Yeah.
So correct
But
format also for the answer,
Mm.
but still.
But when all of the cells are run, you and when you save it, all of the plots and the outputs are also saved along it. So even without running all of the code, you can have it. You can get a sense that if the student actually did it. But
Yeah.
I think it's not a topic for this section. But yeah. You can also replace your paper your paper notebook if you want to, I guess. And at the moment, there is a whole community around Jupyter Notebooks. So there are like a lot of plugins or like other side tools that, for example, you can create slide presentations with Jupyter Notebooks. So it's like a
And I guess
powerful. Mm,
yeah, probably the most common use case is as kind of a scratch pad. So you're not exactly telling a story, you're just seeing what happens if you write this code.
yeah,
And then probably discard it or move it to the
yeah,
correct function or something like that. Which kind of does actually like lead into the pitfalls. So
yeah, that's true.
yeah.
But yeah. But speaking about of pitfalls, Jupyter notebooks are not the answer for everything. Especially the Jupyter notebooks are not good if you have a very complex code flow, and it's like more suitable for a linear one that you run the code block by block. But if you have like a more complex one, Jupyter notebooks are not the answer, and it would just make it very complicated. If you have a large code base, although there are like some approaches to like create a module and like call the module and everything. Personally, I don't recommend it, and I don't think it's a best practice. It's just for showcasing and telling the story, I would say. Um, It is not very easy to write a notebook like Jupyter Notebook without a plugin or without an extra application. Although it's possible to do it in any text editor because it's underneath essentially it's like a JSON file. But with a plugin it's a lot easier. So maybe that's also a pitfall. Notebooks can be version controlled, but again, without any plugin, an additional plugin or like a platform, it can cause some issues, specifically if you have plots or tables embedded, which are the whole point of the having Jupyter notebooks, I guess. So that's also a limitation there. And I don't know still why, but when you're creating the Jupyter notebook, it's not named by default, and it can be actually a very huge problem.
I mean,
If
this
you
is
have
specifically about Jupyter
a Jupyter
Lab,
lab, yes,
actually.
that's true.
Um,
But it's actually like it doesn't look like a very huge downside, but when you are working and it everyone has this experience that they forgot to rename the file, and then after a couple of weeks they came back and like just looking on the untitled files. So when you're creating a one, just don't forget to rename it at the beginning. But yeah, you can look at the our internal page for more pitfalls. And some of the good practices to follow, as I mentioned, always remember to rename the file when you are working with Jupyter Lab. And before sharing and also saving the code, it's always good to run all of the cells, all of the blocks of the code. So you are making sure that everything is supposed as it should be or as you expected it. Uh, yeah.
Essentially, I have over a long period of time developed the habit of always restarting the kernel and always running all the cells from top to bottom.
Mm,
Even if it's a scratch pad, like even if I'm just trying things out, I will never go and run the cells out of order because
yeah.
that just leads to problems. I wish there was a way of completely disabling that feature, but
Yeah, but it's,
no.
it's very good for the linear workflow as I mentioned. So like going block by block, I guess. Yeah. Um, so yeah, maybe we can go to the interface and take a look at the interface very briefly. So, um, if you created the Conda environment, which I guess you did already, you should be able to run the Jupyter Lab. But just to demonstrate, I will bring my terminal over here. And I already have the environment, so I would just go ahead and make a directory like Jupyter Lab demo. I would go inside that library, and by calling the actually my environment is not
Did you? Yeah,
activated,
you
so I
didn't
have to,
activate the environment. Yeah.
yes, I would activate my CodeRefinery September 2025.
So often this would be conda activate, or do we recommend using Mamba these days in the installation instructions? Then it would be Mamba activate.
Yes.
I don't know if source activate will work for everyone, but in some
Okay.
cases, yeah.
Because of the Triton, I'm always like
Yeah,
sticking to
yeah.
source activate, but yeah, but Mamba activate or either source activate and then name of the environment. So it would activate the environment, and then I can run the command Jupyter Lab to run the Jupyter Lab. So what happens is that Jupyter Lab would be starting, and in your recent browser, it would open a new tab or new window, and it would show the interface. So let's wait for it. So it would be done. Yes, and it switched to my browser, so you can see that the interface of the Jupyter Lab is starting, which is very good. But for a second, if I go back to the previous terminal, if you look at the logs here, you can see that the Jupyter Lab is starting at my local host with this specific port. The port and the address can be also changed. And there is also this token thing. So if you want to open it in a new browser, or like when sometimes you're working on a remote server and you're doing like port forwarding to run a Jupyter notebook, it's always good to have this token. Otherwise, Jupyter doesn't allow you to log in. So just to, I don't think I can, it's necessary
I
to
think
demonstrate, but yeah,
at least copying and pasting that full URL should work. I don't know if you can open it as
exactly.
a link,
Yes.
but from the terminal, but on some terminals, just clicking on it is enough.
Yeah. Okay. So maybe we can talk about the interface a bit. So this is one of the actually before that maybe I can go back to the course and like talk about the components and the big picture behind it. So what's happening behind the scene is that we have the Jupyter Notebook server running, which in this case is the Jupyter Lab. And inside the Jupyter Lab, we are creating notebook files, like just to see the interface and like see all of the cells and the segments of the code. At the moment, we are using like my Chrome browser to see the Jupyter, like interact with the Jupyter Lab, but it can be also like VS Code or like any other tools, I guess. And behind the scenes, there is a kernel running, which can be thought as like a virtual environment, which has all of your dependencies and also the dependencies for Jupyter, which is like the IPython kernel essentially, to run the code and show you the output and also render the markdown.
So
So
the kernel runs the code. The notebook file is where you essentially save everything, and the browser just shows things.
exactly.
Yeah.
So now we have an understanding of the big picture. Maybe I can go back to the, oh no, maybe I can go back to the, oh, sorry. Maybe I can go back to
Okay.
the,
Yeah. Yeah.
yeah, to the interface. And the reason is I don't see the tab names, but yeah. So this is the Jupyter Lab interface, and here you can create a new notebook, which would take a look in. You can also like create a console with IPython that you can test like some small commands. You can open a terminal here, create a file with markdown or text. And before creating a notebook, maybe we can look at what is the interface here. So here in the Tree Explorer, you would see all of the name of the file that has been created. The folder is empty. I just created that, so there is nothing here inside yet. This blue button would open a new launcher. Launcher is this specific page. So if I create this, another tab would be created here that is essentially the same one. So for now, it's not useful, but when we are editing a notebook and we want the launcher again, that would be a useful button. So for now, I will close this tab. I can create a new folder here. I can upload a new file, or if I change the folder in like my terminal or something, and this hasn't been updated, I can refresh this file explorer. I can, of course, clone a Git repository, and I can like filter some of the files with like the names or like essentially like a search button.
I guess
Um,
we'll take a look at the, well, okay, the side panels are useful. Like we'll take a look at the Git part at some point
yes,
later.
yeah,
There is maybe like this circle with the square inside.
yes.
Um,
So this is for
is good
the
to show.
kernels.
Yeah.
Yes, at the moment there is no kernel running, so there is I haven't like started any kernel, which again you can think about as like a
Yeah, but
good,
this is kind of just good to know, and you probably will not
yes,
need it today or anytime
yes,
very soon. But
exactly. But
yeah,
when you have like
sometimes there's
multiple
problems.
notebooks running, you can like restart the kernel, which is like restore the memory of the Python interpreter or the R interpreter, in a sense.
But then I
Uh,
think
mhm.
yeah, so I'm just thinking through what we'll actually need for the exercise, and I think that is creating a file and
Yes.
then
Uh,
adding
yeah.
cells.
Okay, so just the last one is that with the Git one, you can actually clone a Git repository, or you can actually initialize a Git repository here. As we mentioned, notebooks can be like version controlled, but there are like some tricks that Jarno would show. So let me just initialize just a Git repository here, so you can like
Yes, that's a good
establish
idea.
like it. Yes, so that's good. So maybe I can go back to the main folder here, and then I can create a new notebook. So as you can see, a new notebook has been created, and this is my file. And always remember to rename the file first. So I would right click on this and rename it to intro. Also, like you can use the shortcuts as well, but don't push yourself to like learn all of the shortcuts. Using with the GUI is also fine. So, sorry, I created by mistake. So, in the Jupyter Notebook, as you can see, we have this sections called a cell, and in this cell, you can, for example, write any code. For example, I would go ahead and from date and time, I would import date and time, and for example, print date and time. Now, see what is the time. And when I'm selecting a file, this blue indicator shows that this specific cell is selected. So I can go ahead and with this play button, I can go ahead and run it. So you can see that the code is run at the moment. The
By the
other
way,
button,
can
Mhm.
people see well? Is the text large enough? You can write in the notes if it's not.
Yes, but I can also increase the font a bit. Is it better
Yeah,
now?
a bit, yeah. But
I can also
I
increase.
mean, also if it's fine, then it's fine.
Okay, okay. I would keep it at this so we can see all of the buttons as well.
Yeah.
So when you're selecting a cell, with the first button would like save the whole um, the notebook and also create a checkpoints like a backup that you can go back into it. You can add a new cell below the cell that has been selected. You can cut a cell and like paste it somewhere else to the code that you if you want. You can copy a cell. You can paste a cell, of course. You can run a cell, and if it's a code one, it would run the code, and if it's a markdown one, it would just render the markdown. And this guy is for interrupting the kernel, and it means that let's say you have a computationally heavy function, or like when you're doing something computationally heavy, and the code is stuck, you can just interrupt it so the computation would pause and the command is not run completely. You can restart the kernel and also run and if you want run some of the cells again, or you can restart the kernel and run all of the cells. So just to show you, I would select another cell, and when I'm selecting a cell, there is also this button that it shows what is the cell type. At the moment, by default, is a code one. I can go ahead and, for example, change it to Markdown. And when it's Markdown, I can write anything in Markdown. So for example, I say this is a large heading, and for example, oh, sorry, this is a second heading. And this is a normal text, or I can like, for example, write in a bold text, or I can write, for example, equations as well, like x equals to, I don't know, sigma I, or y to the power of I, let's say, plus 1. And I can go ahead and run this, and because it's a markdown, it will just render the markdown. So there's a heading, the second heading in the normal text.
Yeah, so rendering means like showing it, like showing what you mean by this syntax, right?
Exactly.
It's like the view mode.
Exactly like the view mode for the, yeah. So now you can see like why it can be powerful, because you can like add the equations that you want to do
Yeah.
before like doing like the coding, and then when someone is following the code or your Jupyter notebook, they can see what are the equations and they don't have to like find in the code. Yes. Okay. If I go back, actually, another maybe something else that it can be useful here is this third button on the left on the sidebar, which is just a table of content. As I mentioned, like there are some books entirely written in Jupyter, so it would just show the heading so you can see. And then when you click on the, for example, the second heading, it would
Yeah.
directly go to that cell.
I've never actually used this, but I can see if you're writing a full
Ah,
book in Jupyter, then this will be useful.
also for like doing some assignments, I would say this is like a very
True.
useful.
Yeah.
But yeah, okay.
Anything longer.
So yeah, I guess now you have a better idea, and now you understand the interface, at least the Jupyter Lab, a bit better. So if I go back to the course page, I guess we covered the navigation and what are the buttons. Um,
And I guess like people can learn the shortcuts and so on if they end up
Yes.
using JupyterLab more.
I guess this is
So
something that you would eventually learn, but don't push
yeah,
yourself to like always
yeah.
yeah.
And like also if you prefer a different interface, then this is completely useless.
That's true. So maybe actually I
Um,
can also use like I can show very briefly the VS Code as well. So as I mentioned at the moment, we are using Jupyter Lab as the notebook server, and like we are using the browser to interact with and create notebooks and everything. But this can be done also in other tools, for example, like in an IDE like VS Code. So if I open my VS Code here, so my VS Code is this. Like I hope you can see it. I would close this error for now. Maybe I can increase the font a bit. Yes. So I'm inside the Jupyter demo lab, and this is the intro file that we created. And as you can see, again, I can like create a new code cell, or I can create a new markdown cell here. So the interface is a bit different, but you have the understanding of what is the code cell and the markdown cell. And for example, I can go ahead and try to run a cell as well. But in VS Code is capable to show you the notebook, but to be able to run the code or like the markdown codes to do the rendering, you need an additional plugin. But if I go ahead and I guess I have the plugin already installed. So maybe I can show you. So if you don't have the plugin installed, you have to go here to the plugin tab, to the extensions. For example, search for Jupyter. The reason that it has been installed is that actually it was installed, but it wasn't um, it wasn't
all right,
reinstalled.
you removed it but didn't update.
Yes, I didn't close the VS Code. Yeah, that was the reason. And the reason is that so this is the Jupyter plugin, and at the moment with the latest version of VS Code, the latest version of Jupyter, which has been updated 2 weeks ago, doesn't work. So in order to be able to use the Jupyter plugin with the latest VS Code version, you have to install a previous version of Jupyter extension. So if you haven't updated your VS Code, go ahead and click on install so you can install the latest version of Jupyter extension. And if you recently updated the VS Code, you have to install a previous version of Jupyter. So to do that, you have this setting button here. So you would go here and then go with the install a specific version, and the 2025.7 for a month of July would work.
I think I used the one from 3 weeks ago and that also worked. It's
For
just the
me,
most
it
recent
didn't
one
work.
doesn't.
Maybe
Okay,
that's the,
well then
yeah.
it's better to go with the 2 months ago.
Okay. But maybe before installing it completely, I can go back to the code and show you what happens if you try to install it to run the Jupyter notebook without the extension. So if I go back here and if I try to, for example, run this Python code, uh, it would suggest that this is a Jupyter one, and it's not allowed. It cannot run it without the extension. I don't use the recommended version because it would just install the latest version. So I would cancel
Yeah.
this, go back to extension, and then install the previous version. So it's good that I installed it before, so it's already cached, I guess. Great. So if I close this and I try to run this, it would ask for the Python kernel, in which I can use the CodeRefinery one that I created with my Conda environment. And now I should be able to run this guy. It's looking at connecting to the kernel. And hopefully this should change. It's a bit long for the first time to starting the kernel,
Yeah.
but then it should be fine.
It should work. It usually does, but this is taking a while.
Yes, let's see.
Oh, well, I mean, we already saw it running. Should we just go do the exercise? Oh, well, actually, it's done.
Yeah. This is
Yeah.
already done. So yeah, that's good. Okay. I guess
Right.
we are a bit behind the time, but yeah, we can go a bit
I mean, it's
on
fine. We
this.
actually do have some extra time.
Okay, so that's good. So the next part is for you to start working and getting some hands-on experience with the Jupyter Notebooks. So this would be your first computational notebook, And in this exercise, you are going to calculate the pi. And in order to do that, we are creating a square, like a 1 by 1 square, and then we are randomly throwing some darts into it, and then by calculating the area of the side, the circle, and also the area of the square, we are trying to estimate the pi. Of course, if you throw more dots, uh, if you throw like infinity number of dots, the whole square should be covered, so the pi should be more accurate. So that's the whole idea behind this exercise, I guess. So I guess maybe like we can have 20 minutes or 15 minutes to do the exercise.
Do
So
you want to show the hint below?
yes, exactly. So go ahead and like run the Jupyter Lab on your time. But actually, there is a very useful hint here. So if I go back to my Jupyter notebook, a Jupyter Lab, and I would start a new launcher because I want to create a new file here. I would start a launcher. I would create a new notebook here. Always remember to rename your notebook first. So I would name it to Pi. And in the exercise, we have this code block that you can copy. And essentially what it does, it would create an iframe and show you this whole page inside the Jupyter notebook. So if I will go here and copy and paste the code, and I would run this block of code. And as you can see, you see that powerful point of the Jupyter that I can like render HTML file here directly. So if you want to follow the exercise, you don't have to switch the tabs. You can just scroll here and follow the exercise very easily. Okay. So maybe we can
Yeah,
add Mhm.
I
anything.
mean, I think yeah, the instructions are pretty clear. It's mainly you create a notebook and then you need to figure out how to get a markdown cell and how to get a Python code cell,
Yeah.
and then copy and paste the things inside and see how it runs. So this is more about the interface than writing the code. Like the idea is not that you write the code. The idea is that you create the notebook and
Yes.
put the stuff inside. So
Yeah. And if something went wrong, you can ask the question and we are here to help.
yeah.
So yeah, maybe we can like set 15 minutes, yeah or no, or
I mean, this actually, like, if there's any problems, then it will take a while. So I would go with
oh,
20 minutes,
20
um,
minutes. Okay.
or let's
Cool.
say uh, until the hour. So it's
Yes.
19 minutes now.
Okay. Good luck with the exercise.
Yeah. And remember, you can ask questions in the notebooks. Not in the notebook, in the in
Yes.
the in the notes, in this markdown notes that we have.
Yeah, got confusing a bit.
You
Yeah.
probably can ask questions in a Jupyter notebook as well and get answers, but that's way more complicated.
Yeah. But in the sharing discussion, we would like discuss
Yeah.
it. So yeah, would be possible. Great. Good luck with the exercise.
So I'll essentially do the exercise here quickly. So I'm using the JupyterLab interface we already showed and using exactly the same features that we already showed. Whoops, what is happening? Okay. To save the file, I need to click here, not press Ctrl and S, because Ctrl and S will try to save the website. So, okay. So I have this file called Python notebook, and I'll just hide this part of the view, maybe zoom in a little bit. And then let's scroll down. So I have already started JupyterLab. Well, I don't need to do that one. I want to use this browser. And then I have done this, shown this web page here. So going into the exercise itself, let's make a new cell first. And I need to turn this cell into a markdown cell. Okay, so I'm partly using this interface because it's not the one I normally use and I don't know where things are. So I will have to also remember to explain what's happening. Okay, so run the markdown cell and we get a nice title. And we can paste in some interesting formulas that explain what we are doing. So this is how we calculate the area of, how we calculate pi from the area of a circle and the area of a square. And those are relative to the probabilities of hitting this. Well, the probability of hitting the square is 1, but the probability of hitting the circle is relative to the area of that circle.
Mm-hmm.
Okay, so then we have one more thing. We have the nice image. I did not change it into a markdown cell, and this is not proper Python code, so it's
Yes.
failing to run it. Let's change it to markdown and run it. And by the way, now I'm already defaulting to running it by pressing Control and Enter. So next time I will press here, but it is the same thing. So the first thing is we need to import the random module and the plotting module to create the plots. So let's create a new cell again, paste in, and now it's code, so I don't have to change it. Okay, and this is Python code specifically. Okay, I'm confused about what I'm scrolling because it's the same web. It's a website in a website. Okay, so we'll set number of points. Let's also take the comment. Why not? Okay, setting the number of points to 1000. I think at this point I will not be scrolling up and down. I'll just look at the window on the side, which you do not see. So I'm here. So we'll create this or run add the code to actually create these random points and see if they are inside the circle and run it. Okay, that didn't take very long. And then this one creates the plot. So it takes all of these coordinates and puts them, makes them visible on the, or draws them onto the plot. Let's run that. So here is the nice little plot. And it's only a quarter of the circle, or quarter of the full dartboard here, but it is this quarter that we show here. Okay. And finally this one. So we compute pi by getting the fraction of the two areas, or the estimate of the fraction, and then multiply that by 4 to get pi. So here we go. That's not exactly pi, but it's also not the furthest possible thing away. So let's run this again. Add a few more points, just to see if we get a more accurate one. It still doesn't take very long, but this is starting to look like it's basically completely covered. Okay, and also pi is a little bit closer. Now I'm going to change that, and then I'm going to talk to you a little bit about something. I don't actually know what. And then I'm going to go, okay, run this. Wait, the mistake I was trying to make didn't happen. Okay, now this is not pi. Okay, so this is probably the most common mistake anybody makes with Jupyter Notebooks, right? So what did I do wrong? I changed the number of points, but then I didn't run this this cell that generates the points. I didn't refresh the plot either. But then this depends on the number of hits and the number of points. So I changed the number of points, but I didn't recreate this number of hits. So the result is wrong. My solution is interrupt the kernel, press stop. Did it do it? Okay, yeah. Maybe it did. Okay, and then restart the kernel and run all cells. And then you can be sure that everything is running in order. Okay, there we are. I made it a lot of dots, so it took a while, but well, still not great. This is it's like close-ish, but not great. Yeah. Anyway, so yeah, that is a common mistake. I'm gonna change it back to the original. And again, run all cells. Oh, restart and run all cells. Yeah. So yeah, so I just wanted to show that because it is essentially like the most common mistake people make, and it is something that I really had to learn out of. So But it is also a powerful thing that you can run things out of order. So you can use it as a scratchpad. You don't always have to run the whole thing to get the result, to change one thing. But it doesn't remember what the state of the notebook was after running cell number 3. It just remembers the current state. And if you change something, run some code, it changes the current state. Okay. So yeah, that is a bit of a complicated thing, or it can be hard to debug, but the simplest way to get around it and avoid debugging it is to just kill the kernel and then run everything from the beginning to the end. Yeah. Okay, but that was the exercise, and also it's time for a break. So let's take a 10-minute break and see you back here at 18 past the hour. Yeah, that's all. Hope you had a good break. So I'm okay. I'm still on the same page with the exercise. And we actually have a full notebook here in case you are joining us now, or you were installing the Conda environment while we had the exercise time. So you can continue from there, or you can do the exercise and start listening when you're done. That's also fine. One thing I didn't mention is that, I mean, clearly this exercise is in Python. We already mentioned that you can do you can use other languages than Python. You can use R and Julia and many others as well. So there's a list of supported kernels here. A kernel is essentially a way of connecting to a specific programming language and running things from the notebook. And then, yeah, our Markdown and Pluto.gl, Pluto for Julia is our other alternatives that are very similar to Jupyter Notebooks. Okay, but yeah, so the main thing though from here is we have essentially packaged the entire story, the calculation of the value of pi, and the code that actually does the calculation, the results, and all of the reasoning into one file, like one consistent thing that we can then send to, for example, our supervisor or the person who asked us to do this exercise for a course, or whatever the situation happens to be. So that's really useful.
Exactly.
Okay, yeah. Okay, but then there's a downside. So version control. And it's not actually that bad. So Jupyter Notebooks are JSON files. Let's say, can I open this as a text file? Have I saved it? No. Okay.
I guess you have to
There's
rename
this
and then.
dot here. It is saved, right?
Yeah, save, but the kernel is running. That's why you'd see the.
Yeah. So, oh, right. That's it's showing that there's a kernel. Okay. If I name it to JSON, which is standard for a JSON file, then I can open it. And this is not exactly what I wanted to. I mean, this contains all the cells and all the data, but let's do a pure text file. So we talked about Git a few weeks ago a lot, and we have used it all the time. Git is really good with text files. And this is a text file. So there's a collection of cells, it's a list. There's a cell type, execution count, which is displayed in the notebook. There's some metadata and the data. Then there is if there is an output, then there's output. So okay, so somewhere here we have, this is still a plain text output, I think. No.
That's the image from that we from the exercise that we imported.
Okay, yes. So this is an image. This is not very nice text. It's actually a binary blob, but that wasn't actually the plot that we made. we finally get to an actual source code. This is a code cell. And here we have a code cell. So the output, this is source, where's the output? Okay, here, 3.14. Okay, so this is an output. This is the actual source code. Interesting that it's not in order. Is it alphabetical? Yes, it is. Okay, it's alphabetical.
Yeah.
That's one. Right. Okay. So I mean, it's text. You can version control this. It might not be fun to look through this and try to figure out what's going on. And this image here is not going to look nice if you're trying to use Git directly. But it's not that bad. So let's turn it into a notebook. It's an IPython notebook. And open it. Okay, so we have an extension called nbdime. I guess we should, yeah, here's a link to it. So this is the lesson page again, the lesson materials. So there's an extension called nbdime that works with JupyterLab, and that allows you to actually look at these notebooks properly in a version control interface. So I mean, you can go here to the Git tab and look at this. These are all new files. So let's make a change. Or rather make a commit first and then make a change. Okay, there's also a checkpoint file, which is nice, like Hossein mentioned earlier. Okay, and then I want to make a change to the actual content. So let's again go and increase the number of points. Now, if I look at the change, okay, I need to click this button, this with the plus and minus here, and maybe hide the version control section. So it looks nice, and it actually shows you which cell and what line on that cell and so on. It doesn't just look like a JSON file. Then we can also go ahead and execute. Did I execute this one? I think so.
Not yet.
Okay. Whoop, there we have a new image as well. So if you just look at the text again, it will just show the entire binary blob as a difference, which is huge. If you look at the difference from here, I didn't save the file. Okay, now if you look at the difference from here, it shows that there's a change here. There's a change in this cell, but that's only output. So there's no actual changes here in the code itself. Same here. Output's changed. I guess this doesn't look that great either. But well, you can actually see both images here. I think if you like zoom out, maybe it looks better. I don't know. Not really. I'm actually a bit disappointed by how it looks like right now. I'm used to it looking much better. But it shows that the picture is different, and you can actually see a preview of both images. So that's much more useful than just saying the whole binary blob is different. And the output, there's an output here and it's different. Actually, here it's only the run count that has changed in these two cells. Okay. So now we can go ahead and add this. So what should we say? Increase the number of points. Okay. Okay. So next, going back to the materials, should I also show this in VS Code? If you look at the version control interface, if you're using VS Code, you will see that the Jupyter extension actually makes it look nice, and you can so you can see the differences in a nice way. One other thing is GitHub. So you've been using that a lot as well. If you haven't done anything uh, to make it look nice, then it will not look nice. So we can go ahead and look at the notebook. So this is actually the example. This is the solution to the exercise, or the notebook where you can continue from for the next part. But this is now looking at the difference between two different commits. And this is not very useful. I mean, I see that the image is different,
Yeah.
but it's like not very nice to read. So there is a way of, there's a feature preview. So if you click on your profile, feature preview, there is this rich Jupyter Notebook diffs. If you enable that one, this has been in beta for, I don't know how long, or preview for, I don't know, like as long as CodeRefinery has existed or something like that. So when you enable that and you reload the page, now it looks quite a bit better. So here we again have a better picture of what has changed on these cells, these code cells, but also the images now actually display correctly. So this is the old image and this is the new one after the commit. Some colors have changed and the size has changed.
Yeah.
Okay. One downside though is that when Git remembers everything. It remembers all of the previous versions. So if you keep changing an image or a video and you commit those changes, you will keep actually all of the versions of that video. And if it's an image, maybe it's not that bad. If it's a video and it's a big one, it might take a lot of space and take a long time to then like clone the repository or push and pull. So yeah, that might be then good to remove the image at some point. But okay, it works still pretty well. So we did this comparing notebooks locally already. And there is nbdime from the command line. I don't know, do I have actually these commands? Should we try?
Yeah, but I guess the audience gets the idea that the Jupyter Notebook works with version controlling, but there are some limitations.
Yeah,
And you also have to
yeah.
enable some feature or install a plugin or something like that.
Yeah, you always essentially have to install something to make it work. And for VS Code, it's the same Jupyter plugin, which is nice. But it's interesting that for Jupyter Lab, you still need to install something to make it work. Like it doesn't work out of the box.
Yeah.
Yeah. Okay.
I guess that's
Yes.
good.
So
Yeah.
yeah, let's go on.
Maybe we can go with the sharing. Yes.
Yeah. So, but yeah, I mean, essentially, you probably do want to enable those features in whatever editor and interface you're using, and especially if you're using GitHub. Okay, but yeah, then we'll talk about sharing notebooks. So we have talked a lot about sharing code, and the upsides are essentially the same. But often it is also useful to specifically share notebooks for documentation and to show how to describe how the process works to generate your paper and so on. So there's a bunch of ways of doing that. And the simplest one is to put it on GitHub or GitLab or any interface like that, and people can see it. You can turn it into a website that looks nicer, and it's a bit easier to access. And those are essentially static options. So people cannot edit the code and they cannot run the code, but they can see the entire story and they can see the results. So those are nice ways of doing it. But then there's also ways of sharing it that make it actually dynamic, where you can edit it. So we already talked about Binder, and we showed you a couple of notebooks on Binder. JupyterLab supports sharing like via Google Drive. Okay, I'm always surprised by that, but that's a relatively new feature. And then yeah, there's a bunch of other options. There's Jupyter Lite and EGI notebooks that help you actually share a live version of the page or of the notebook. Okay, so one option that we might as well show you rather than just describe is, so here we have a file. So what is happening? Okay, so we have the file selected here. We can export, save, and export notebook as, and then we can save it as, say, HTML. Okay, this is going into downloads, I guess, that's fine. Whoop, and we can open it. So now this is a website that you can send. You can put this on GitHub and people can open it on github.io, or you can just send it to people and they can open it without any editors and without any viewers, because it is just a website. Okay.
But it's an HTML1, so you cannot actually run the Python code, right? You can just see the
Yes, you cannot run the Python code. It's purely HTML. There's also Google Colab, Calc, and so on. These are commercial offers with free plans, which means they are by commercial companies.
Yeah.
And yeah, they're also pretty good options. So it really there's a lot of options and it depends on what you want. We are going to do this as an exercise, right? Yes.
Yeah.
So we're going to have an exercise where we share a notebook on Binder. So to do that, though, what you need to do first is have a Git repository with a notebook. So if you didn't already, there was a button here to initialize a repository. And then, I mean, if you were here in the first week, you know the steps to push the notebook to GitHub. And I'm wondering, should I show that? And how should I show that? Because I do not have there is no interface for it here.
I don't think you can push it from there.
I can open a terminal.
Yes.
And then I have to create a GitHub repository. And here it's important. So Py example. Okay. So here it's important to, first of all, make it public if you're sharing it, and start with no README file, no git ignore, and no license. Essentially an empty repository. And the reason for that is that we already have files in this existing Git repository. Actually, we can copy the command from here. Git remote add. So we already have files in here. So if you create any files in the remote repository, it will refuse to push. Okay, so I'm going to do this step, and I probably should be a bit more explicit. So this is preparation for the exercise that you will also need to do, but I don't think it's 100% clear on the exercise page. So you need to have a Git repository that you push to GitHub, and then you can do the binder exercise. And preferably the Git repository should have a notebook in it, so the exercise notebook is a good one to have. So I made a branch called main. I'm just copying these commands from here and running them in a terminal. Another option is to use VS Code. you can just publish to GitHub. There's a button that says publish to GitHub, and that should work. Okay, so now I have a Git repository that I can actually push, where I can actually push the changes to GitHub. So if I reload this, I probably have it. Yes, I have the notebook here. And that is, so let's go to the exercise. That is essentially the starting point here. So you create a repository, and then you need to add some files. So for Jupyter Notebooks, our notebooks, it's a bit different. And after that, you should be able to launch it on Binder. So the exercise is to do these steps and to modify your notebook on Binder. I definitely shouldn't go any further in it because then I would be just doing the exercise. Is it clear? Because the reason I'm still talking is that I feel it's a bit unclear.
I think it's clear. Yeah.
Yeah. So follow the instructions here, and if you have any questions, then let us know. The end result is that your notebook should be on Binder. Right? It should be online and in such a way that you can edit it and rerun things and fiddle around with things without actually having Jupyter yourself. Yeah. So we'll go for, is 12 minutes enough? Because it says, let's say 15 minutes.
Yeah. Or 15.
15 minutes, yeah.
Okay. So
Okay, welcome back.
welcome.
Only 2 people have voted that they are done with the exercise. So, okay, now there's 1 more vote.
Great.
If you have questions or if you had trouble, let us know. But yes, so I think I will start going through the steps a bit already. Oh, it takes forever to launch. Okay, yes. It's building the environment for the first time. It does take a long time. Let's see how quickly it happens for me. And while I'm doing this, you can also finish the exercise if you have, if you're still in the middle of it. Okay, so I'm going to actually move this window out of the shared area, and we see my repository with the notebook in it. And the first step was to create a file. So here, create a new file. It's called requirements.txt. I should be typing here, requirements.txt. So this is a relatively standard way of telling what Python packages a program needs. And what we need is matplotlib. And we're giving a specific version of it. And this is telling Binder and other programs also what Python packages we need. So there's different formats for different languages usually. Okay, so let's commit the change. Create requirements.txt is actually a very good description. So let's keep it. And that is in fact enough to run it in Binder. So then I'll open my binder.org. We'll move it to this window. Okay, good. And I need the repository URL, which I get by going to the repository, to the main folder. And actually, it's probably this URL, right? Actually, not exactly. Yeah, it's without the tree and the main. So it's like this, I think. We're taking the main branch, so not writing anything here. And the file is actually called py.ipynb, IPython notebook. Okay, and that creates this URL. There's also a batch for README file. So we can copy that and create a README file. create a new file, readme.md. So markdown, MD for markdown, which is also relatively standard, at least for GitHub and GitLab. Okay, commit changes. And again, the description is actually pretty good. So the default one, create readme.markdown. Although the only thing we added there is this launch binder. So that actually is this link essentially, or a link to this URL. So we can go ahead and link here. So now it's actually, I don't know what's happening here. But it's essentially creating a not exactly a virtual machine, a container that can run the notebook and that then has the requirements, the Python packages installed that we need. Okay, that was surprisingly quick. And it's displaying the notebook nicely. So let's run all the cells from beginning to the end. This might actually, yeah. Okay, it didn't work. This is interesting. It's also jumping around a bit.
Oh, it's weird. It jumps around, but
Okay, that's better. So it must able to run everything else, but this one, matplotlib, the plotting library somehow fails.
I think it's because the inline thing, or no? Oh, okay.
There's a new version of NumPy. So we are using such an old version of matplotlib. So let's go back a bit. Yeah, yes, leave. So we're using such an old version of matplotlib that it actually, like, the current version of NumPy doesn't work anymore. So we can try removing the version. And I'll just keep update.requirements.txt. This is not a good description, but it's good enough. Okay, somebody used matplotlib 3.10 and it worked. That's nice. I'll just try that again and also then see what's next in the materials. So there was this optional exercise about looking at the activity repository and then one that mentions Python widgets or IPy widgets. So I will actually skip those and go directly to a section and the next section. So the next section is summary, but we'll go to examples of Jupyter features, an optional episode, and specifically from here, widgets for interactive data fitting. So I will again move this out of the screen share. Now we're in a binder window. So it's actually here, it's opening the binder exercise, the result. So I can try running everything again. Okay, and this time it works. Okay, so that's Binder. It looks exactly the same as JupyterLab, but the point is that it's not actually running on my laptop, so I don't have to have anything installed to run it. Right? Anyone can go to this website and see my notebook and run it without having to install anything. It's a very useful way of sharing your results. Okay, so I'll also close this one. Yes, leave. And then we'll go to this widgets for interactive data fitting section. So this is in Jupyter/examples, unless there's some questions. Okay, no, we're going well. Doing well. Okay, so let's create I think a completely new notebook. Oh, is it widgets for interactive data fitting? No, that there's a separate part that introduces widgets, and that seems to come later. Like, are these, or did I skip something that I was supposed to?
I also got confused. It should be there's a widgets one inside the shell command, and
Okay, yes. So let's go back to the Jupyter Notebooks main page. And from there, go to shell commands, metrics, and widgets. And here it's relatively close to the bottom of the page. Well, actually here, halfway. So here's the widgets section. And the link, I will put it in the notes. No, that's the, okay, widgets here. Okay, so now it's in the notes. All right, sorry about that. So we got confused about our own thing. Okay. I mean, mainly because the widgets is late in the title of the page, which I should read the whole thing. Okay, so I'll create a new notebook. You can do it from here. From here, from the launcher, or you can right click and new notebook. And it's a Python 3 notebook. I'll close the extra one. Oh, it's untitled. Okay, let's call it widget.ipy notebook. Okay. And if you're in the CodeRefinery environment, you have the IPy widget installed. So this should run. It works. Otherwise, you need to install IPy widgets in your environment. And then to use the widget, we need to define a function. So we'll give a function with 3 arguments, x, y, and s. And it just returns x, y, and s. So it's a very simple function. But the point is we need we will make a widget that allows you to change those arguments. So we'll use the interact, which is this one that we imported. So the interact widget, we give it the function as a parameter, and then we give initial values to the parameters. So x equals true, y equals 1.0, okay, comma, then s equals hello. Okay, I managed to write it correctly. Good. So now when we run this, it will give some well, widgets that you can use to adjust these parameters. So x is true, so it's a Boolean. It's either yes or no. If you and this, by the way, this part is the result of the function. So it just returns the parameters. So it looks like this. But if you send it a false, then it returns false, and otherwise it returns true. Okay, you can, this is a floating point number, so you can change the value. And this one is a string, so it gives you a text box.
Yeah. So essentially the widget is like, instead of like changing the code, you can play with the hyperparameters and your the output with some widgets and like some buttons.
So
But
it essentially it runs the function with those parameters and then produces the result. So you can show different. You can allow people to interact with the code in a more user-friendly way. So let's do another example because we have a few minutes, and
maybe we can do the pi one actually and like increase the number of the.
yeah. So this is actually like essentially next in the, well, there's a few useful metrics commands, and then there's the playing around with the widget. So I'll essentially copy the code from there. So we get the interact from widgets, and we get widgets from widgets, IPy widgets. And we also get random. Okay, run that. Actually, we also need matplotlib inline. Put it in a different cell so that we have this magic command on top. I don't know if that matters. It might. Okay, and then the rest is creating functions. Place this one here. So this is the throw darts, create plot, and run the whole experiments, which means first throw darts and then create the plot, and then print the value of pi. So this is the exercise we just did. We did an hour ago. That calculates the value of pi. So we could run experiments with 100 points, or 1,000 points, and so on. So people can adjust it here, but using a widget, it looks nicer. So we previously used the interact widget, the interact function, and we can tell it the number of points equals, give it starting value 100. Okay, and that gives you a nice widget. So, did it actually run though?
I think it got an exception, and do you have to run the experiment?
Yeah, okay, let's run it again.
Yes. Because
I
when the
don't think
number
it's
of points are
rerunning.
0, it got divided by 0. So
Yeah, so yeah, there's that is one of the points of the exercise. Like there is a value that you can slide to, but that you shouldn't use. But it doesn't redo the image, does it?
um,
I'm adding a lot of points and it's not rerunning, recreating the plot.
oh, interesting. Did you restart the kernel already?
Yes, I did. Stop the kernel, restart, run. Okay. Well, let's see what happens if we make it an integer slider. So this is why we imported also these widgets, because this gives us some control of this number of points value. So we get integer slider, int slider, and there we can give it a minimum. Let's say minimum is 100 points. We can say max is what, 10,000 points. And we adjust it in steps of 100.
Yeah.
This is going off the page. Add some line breaks. Okay. And then the starting value is 1,000, and it's again going off this page. Fine. It's not going off by that much. We could also do it like this. That looks a bit better, and now you can see everything. Okay. So when we run this, we should get a better slider. Oh, now actually the plot is better. So you can adjust it. No, the plot is not changing.
Oh, okay.
I don't know why.
Weird.
That's weird.
Can you stop the Jupyter Lab and start it again? Maybe that's the.
Actually, so the maximum value in the notes is 10,000. That is not going to solve the plot problem.
Yeah, but yeah, I guess it's a issue with the Jupyter Lab. Can you maybe restart that as well?
Restart Jupyter Lab. I can do that. So I have it in a terminal, so I'll just stop it from there, restart, and it opens a new one. Okay, I'll leave the previous one. Okay, and now we have this widget file here. Okay, and we can try running everything. I mean, it's not that bad if matplotlib doesn't work perfectly with this, but it would be nice to see.
There's one comment in the notes about the inline command.
Okay, we
Might
can
work
try
if
without
that's
the
removed.
inline.
Yeah.
So restart and run. Okay, that actually fixes it. Interesting. Okay.
Yeah, thank you.
So it works better without inline plots. All right. Okay, so yeah, that's something to play around with. That makes these pages even more interactive and easier to use for someone that doesn't actually write Python or any other or some other programming language that you're using. So there's also R Shiny, which I should again display this page. So R Shiny is an alternative similar to IPyWidgets for R notebooks. And there's a gallery of examples, nice ideas that you can look at. There's also other useful things here to look at that I didn't actually prepare to teach, or check that they work on my system. But we do have a bit of extra time. We probably should just end early because we don't have that much extra time. If you have a very good question, or even not such a good question, but something that's interesting to ask, then please ask it in the notes. I will, whoops, what did I do? Okay. So I will move on to the summary page. So in Jupyter Notebooks, we have a summary page here. And oh yeah, there's some recommendations for longer notebooks, like how to
We
make
have a
a
question regarding the Jupyter Rich diff on GitHub. Can you show it again?
Yeah. Oh, so the question is essentially, can you show it again? So do we have a good example? I mean, we probably actually have just in my own repositories. The last one should be the Pi example. And then let's update requirements. Is Pi notebook was updated in this. Okay. So now we maybe have a diff of a notebook.
Can you
Yes.
enable the feature again to see?
Yeah. Yeah. So it was here in feature preview. There is this rich notebook diff. So if this is disabled, and I reload the page, then the diff of the notebook doesn't look as nice. Okay, no, it doesn't show it at all. So now it's essentially, it looks like the diff of the text that's actually the notebook file. So it's a text file. It's a JSON text file. So it's not that easy to follow what's happening, especially the image is, again, quite horrible. Yeah. Somehow the old image is bigger than the new one, even though the new one has more points. Oop, that was not the right button. Okay. So let's go again to click the profile, go to feature preview, and here you can enable rich Jupyter Notebook diffs. And then the diffs of Jupyter Notebooks will look a lot better. Okay, here we are. So that's a lot clearer. Okay. Now, this is the summary page that I am already on. Okay, so let's go through the summary. For some reason, my doorbell is ringing. Again, it's ringing twice, so it might be important, but let's see what happens. So we have talked about Jupyter, basically. We've gone through some interesting and useful features, and there's all sorts of things. All sorts of details that make it useful, like the fact that you can package it in a single file and easily send it around, and also that it shows all of the results very close to your code. It's very good for documentation and so on. And also those same things, partly, they create some problems, like the fact that you can execute the cells out of order. Things happen sometimes in unexpected ways that are important to remember. And I mean, basically, they will just cause problems, and you will debug those problems. And at some point, you will remember that, oh, well, maybe if I run it from the beginning to the end, then hopefully it will work. And it's also very easy to write a Jupyter notebook where if you run it from the beginning to the end, it will not work. So it's good to test that every now and then. But yeah, and then there's a few, we went through a few different ways of sharing notebooks, and well, essentially we showed the binder thing, but there's plenty of other options, many different ways of sharing them and sending them to people. So yeah, I mean, it's one of those, it's a very useful way of coding and sharing code, but it also has its own downsides, especially if your code gets longer, then it's like impossible to follow. So is there anything you want to bring up specifically?
I think everything was fine, and the main introduction was why Jupyter Notebooks could be useful and why, in some cases, they are not the best solution. So yeah.
Yeah. Okay, and of course, it's also important to remember that there's other options. So there's many
Yes.
different notebook alternatives, even though we only showed Jupyter Notebooks and for different languages. And yeah, I mean, this is an example of well, partly the kind of thing I was talking about where it gets complicated, but also you can take, when your code gets long and gets fancy, you can start taking parts out of the Jupyter Notebook and putting them into your own module. And that is essentially how like most modules are born in scientific coding or scientific software. So you start writing something and you notice that it starts getting complex enough that you want to actually take functional pieces and make them independent, make them modules. So that's something we'll talk more about in modular coding, but that's something that's very, very important, very useful for dealing with notebooks. Okay.
All right. Thank you so much, Hossein and Jarno, for today's session. I hope everyone who watched and followed until the end got something out of this. We have added a feedback section in the very end of the notes. Maybe Jarno can move there and show it. So if you go to our notes and then scroll all the way to the bottom, there's a small section. So next week we will actually be talking about automated testing, and the week after will be modular code development. So if you have no idea what testing is and how to run it, and especially how to run it automatically, next week is the time and day for that. That basically means that you will learn how you may prevent yourself and others from breaking your running code. And we will have examples in the lesson materials for many different programming languages. So even if you don't code in Python, you might get something out from that lesson. And then we're asking, how was your feeling today about the speed, about the level of the lesson and the materials? Did we go through things too fast, too slow? Did it feel too basic, too advanced, or just right? And also, do you feel like you will have use for what you learned today in your work? In the very beginning, we discussed briefly how Hossein and Jarno also are using Jupyter in their daily life as research software engineers. And then if you have any specific things that you liked about today, please let us know as well as if you have anything that you think we should improve for next time, because we are running these workshops like twice a year. So we always are curious on what we can do better to make it most useful for you as a researcher, so that you can now go home and apply what you have learned to your own workflow. That is, of course, the wish. And with that, I think from our side, everything is said. Do you have any last words to share here?
Not from my
much, I
side.
mean.
Yeah.
Yeah.
I
I
would
mean,
say
a
just
lot of
thanks for
this
joining.
is sort of relatively like, and if you have already used Jupyter Notebooks, especially, like this is this lesson might be relatively low level, but it is also something where a good amount of the mistakes and bugs that actually happen because of Jupyter features. So it's like when you actually run into them, it's good that you have some kind of memory of like, this is a thing that I should check.
Yeah, and also know that the materials will stay available where they are. You are very welcome to share it also with your colleagues or come back to them later. And maybe here at this time, I will also add the link to our chat. So in case you are now going out to work with these topics or also topics, other topics from the workshop, and you have any questions or would like to ask something more from the instructors, we're all usually hanging out in the CodeRefinery Zulip chat, where you are very welcome to join. We have there one channel that is called Help, where you can post all your questions, and then you will have some multitude of people happy to help you with especially topics related to the workshop. All right, then unless Enrico has anything else to share at this point, I think we can close down the stream and hope to see you all again next week. Same time, same place. We'll again send an email with preparations and when the stream starts. And have a good afternoon or whatever time it is where you are, and rest of the week. See you then. Bye-bye.
Bye.
Thanks for joining.